Energy. When I say this, what is the first thing that comes to your mind? Is it the drastic increase in its price which comes along with its higher demands? Or is it the problems that come along with climate change and global warming? Whatever it may be, we all know the current ways of energy production is just not sustainable. We all know coal is dirty and produces huge amounts of CO2. But what about the major renewable sources of energy? Well, solar can be blocked, wind can stop flowing, making them unreliable and not a constant source of energy. And well, hydroelectric stations just cannot be present everywhere. Then, is there no possible way to solve this energy crisis? Well, there might just be one that can provide an inexhaustible source of energy with almost no waste products that are harmful for us as well as the environment. Then, what is this almost magical sounding source? Well, it's nuclear energy. No, not the one you're thinking about. There are two types of nuclear reactions: fusion and fission. Accidents in fission power plants caused the 1986 Chernobyl meltdown and the recent 2011 Fukushima disaster. And apart from that, they also produce dangerous radioactive waste that need to be locked tight for around a couple thousand years. But that said, around 440 fission power plants around the world provide around 10% of the total energy we consume and save approximately 528 million metric tons of carbon dioxide each year, which would have otherwise been produced by fossil fuels. But fusion, on the other hand, is a whole different story. It has no long-lived radioactive waste like its counterpart and only produces helium as a waste product, which is an inert non-toxic gas. All of this sounds so nice, so why are we not using fusion yet? Well, firstly, let's try and understand how it works. Fusion is basically forcefully combining two nucleuses of any light elements or element to produce energy. I say forcefully because the two nucleuses must overcome the Coulomb's barrier or the electrostatic force of repulsion, which occurs due to the presence of positively charged protons in both the nucleuses. So to overcome this force and undergo nucleosynthesis, they must get extremely close to each other, to around 1 into 10 to the power minus 15 meters or a femtometer. So why does any of this have to do with why fusion is not yet feasible? Well, we need to heat up the atoms to extremely high temperatures for them to overcome the Coulomb's barrier, which takes a lot of energy in itself, but has still been done and proven. However, the main problem is not making fusion occur, but rather sustaining it, which requires even more energy at temperatures below 100 million degrees Celsius, as fusion is not self-sustainable below this temperature on Earth. As we can see, fusion is currently still in its early stages, but we have found two promising solutions for fusion to become sustainable in the coming future. One is ICF or inertial confinement fusion, and the other is MCF or magnetic confinement fusion. In inertial confinement fusion or ICF, they usually use super strong lasers to get temperatures and pressures high enough for fusion to get going. On the other hand, magnetic confinement fusion uses superconducting magnets to create extremely strong magnetic fields to squeeze and heat up the fuel to fusion conditions. But rather recently, HB11 Energy, a spin-out company that originated at the University of New South Wales in Australia, took a completely new turn to fusion. Instead of relying on deuterium-tritium reactions, both of which are respective isotopes of hydrogen, and incredibly hot temperatures like many other attempts at fusion, HB11 Energy used hydrogen and boron-11, which are plentiful in nature, along with using only two special lasers, where one establishes a magnetic containment field, while the other triggers the fusion chain reaction. With such progress and innovation in the recent years, fusion might soon become realized. If it did, then it would probably cause a huge paradigm shift that could be compared to the Industrial Revolution. Like anything else, it would have certain drawbacks, like the other competitors in the energy industry will take a huge hit, and the non-renewable energy industry like coal and oil will most definitely go out, and take the jobs and incomes it produces for the economy along with it. However, I would say the pros far outweigh the cons, as new opportunities in the fusion industry itself will open up, but the biggest opportunities will not be the ones that come in the fusion industry as such, but the ones that come up along with it. Like the possible use of affordable fusion propulsion systems in rockets or spacecrafts, which would make spaceflight more economic and accessible in the long run. And if everything went right, soon we could even get into space mining of asteroids or other celestial bodies close to us, meaning more jobs in that industry as well. And apart from this, more energy dependent industries would also grow due to lower cost of electricity like the manufacturing industries. So we could say the loss of income and jobs in a few industries will be overly compensated with a plenitude of income and millions of new jobs in various novel as well as rapidly growing industries. But the best of all, people could now have clean, guilt-free energy for low cost without worrying about climate change or global warming. And what's more, a major reduction in energy prices could lead to an economic boom, as energy is one of the main things that eats up our income. This previously lost income could be spent elsewhere, meaning more investment and consumption in the economy, which would not only lift an individual's living standard but also the economy as a whole. So, in summary, you could say fusion could make the world a much, much better place. I hope this has changed your view on fusion and what it can do for us. Thank you very much for watching.